Ohm's law is the next lesson we have to discuss on electricity. So when it comes to Ohm's law, this I think you might have already learned in O levels, but even if you haven't, it's not a problem. So I've already written the law, the definition. When temperature and other physical properties are kept constant. Now when you say temperature and other physical properties, they're actually speaking about a resistor, the factors which affect the resistance. Now we know the equation for resistance, that is R equals rho L over A. So when you say temperature, we know resistivity is affected by temperature, and other physical properties, the length, the area, and the nature of the material. Okay, so it's actually indirectly it speaks about resistance. So when you keep all these temperature and other physical properties constant, that means that's an indication that resistance is constant for that particular conductor. Okay, so you have to know this law. Sometimes you will have to write this down as a definition at your exam, so you have to be absolutely sure about this. When temperature and other physical properties are kept constant, the potential difference across a conductor, when I say a potential difference, it can be called voltage too, is directly proportional to the electric current through it. So in a nutshell, what I'm trying to say is, let's say you have a resistor and you have connected that resistor to a battery, and through this resistor there's going to be current. If I increase the number of batteries, I will be increasing the amount of voltage across this. So when I increase the number of batteries, the current will increase. That's what it says. So for one battery, if it is 1 ampere, for 2 batteries it will be 2 ampere, 3 batteries 3 ampere, likewise directly proportional. All right, so if you put that statement into an equation or into letters, into symbols, it will be V directly proportional to I, and we know to get rid of the proportionality sign, we introduce a constant. In this case, the constant we introduce is the resistance R. V equals IR, where V is the voltage. We use volts, the SI unit we have discussed already. I is the current, ampere will be the SI unit, and resistance, for resistance we use capital omega, letter capital omega, which is ohms. We call it ohms. Alright, now resistance is we have already defined what resistance is, but I don't think we discussed the dimensions of it. Now what are the dimensions of these two? We have already discussed that. Now if you can't remember at the exam, suddenly you might come across a situation where you will have to write the dimensions of voltage. Now then let's go for the definition of voltage. What is the definition of voltage? Voltage is work done per unit charge. So that is work over charge. Voltage is work over charge. So if you want to find the dimension of voltage, you have to find the dimension of work over charge. And what is the dimension of work? That is ml squared t minus 2. And what are the dimensions of charge? Charge is current into time, so it is IT. So finally you will end up in an equation ml squared t minus 3 I minus 1. We have already done this earlier. These are the dimensions of voltage. I hope you can remember that. And what about the dimensions of current? Dimensions of current is I. There's no change in that. So for voltage, the dimension is ready here. I will write it again, never mind. Voltage for dimension is even I can't remember these things at exam, you have to quickly find out. Minus 1. And for current, the dimension is I itself, because current is a basic or fundamental SI unit, so it has a specific dimension. Now for resistance, what is the dimension? Then we have to alter this equation. For resistance, you will get a new equation now. R is equal to V over I. So that is the equation for resistance. In that case, for the dimensions of resistance will be dimensions of voltage divided by dimensions of current. What are the dimensions of voltage? Let's substitute here. ml squared t minus 3 I minus 1 divided by the dimension of current is I, and finally you will end up in ml squared t minus 3 I minus 2. This is the dimension of resistance, yeah, right? Then if they ask you to find the dimension of resistivity, you will have to substitute this for resistance, and length and area, you of course know L and L square are the dimensions. Then you can find the dimension of resistivity. We have already learned this equation of resistance, but unfortunately we did not know the dimensions of rho to find out the dimensions of resistance, but now we have a proper solution for that. So this is the basic explanation for Ohm's law. You have to remember this. So whenever you see a resistor, let's say for example where there's a circuit and there's a resistor like this is the symbol we use for resistor. All right, and then there's a current going through that resistor, let's say current, and then across that there will be a potential difference V. Then the resistor will have a resistance R, then let's say this is 1 ampere, this is 0.5 ohm, and if they ask you to find V, then always you can use the equation V equals IR, and for V it is IR 1 into 0.5, and the answer is 0.5 volts. Simple as that. Okay, right? For any resistor you can use this equation if you know the current and the resistance. If not, the other way around, you may say you know the current and the voltage, you have to find R, or sometimes you will know the voltage and the resistance, you will have to find I. Simple, not a problem at all. You can do it, get it done. Fine. So that's the basic introduction to Ohm's law, and based on Ohm's law there are certain graphs we plot. Alright, so the graphs, there are two types of graphs. I mean, it's the same case, but there are two approaches. Now let's discuss what that is all about. Let's start with V versus I graphs. So when you say V versus I graphs, we should know V is in y-axis, I should be in x-axis, like velocity versus time graph. So if I use this equation, I will make a small adjustment and write V equals Ri. Okay, I and R are just interchange, there's no problem in that. So when you compare that, it looks like y equals mx curve for you directly. You can just check y equal mx. Right, so there are three kind of graphs, actually four, but the fourth one is in electronics, so we don't have to worry about that much. The three graphs you will have to know. Okay, three graphs. So there are three graphs, and very important factor here is the gradient. The gradient is R. Gradient is the resistance. So we know the shape of the graph depends on the gradient. If the gradient doesn't change, it will have a shape. If the gradient increases, it will have a different shape. If the gradient decreases, it will have a different shape. Likewise. Alright. So there are three types of graphs. I'm going to plot now, and let's discuss one by one. So these are the three cases we need to know about. So the first case is called ohmic conductor. Ohmic conductor is a conductor which obeys Ohm's law. Mainly all the metals, metallic conductors, graphite. So these conductors, they obey Ohm's law. What is the meaning of that? When you increase the voltage, the current will also increase. Alright, fine. So V versus I graph will look like this. That's the case. And here the important part is, what is an ohmic conductor? The resistance will be constant for the ohmic conductor. So I'll just say R for resistance, it will be constant. It will remain constant. It won't change with time significantly. So it will be, then you will get a straight line. Why a straight line? Because the gradient is the resistance. As long as the gradient doesn't change, the graph will be a straight line. And then we have semiconductors. In the previous lesson also we learnt about semiconductors. In semiconductors, the electric conduction takes place due to charge carriers such as free electrons and holes. In semiconductor, what happens is, when you increase the current or when you increase the voltage through that conductor, it gets heated up, so it releases more charge carriers. We have learnt when in a semiconductor the resistance reduces. Resistance reduces with time, because it releases more charge carriers. So here what happens is R reduces. I'll just put like this, R reduces. That means gradient also reduces as the current is increased. As the current is increased, it gets heated up, so more charge carriers are released, hence the resistance reduces, so the gradient also will reduce. Okay, so these things I'm not gonna give you notes. I want you to make your own notes, then only self-learning would be good. Fine. And then finally we have something called filament bulb. You might have experienced this, the yellow color bulb you have at home. If you turn it on for a while, and if you keep it on for half an hour or 1 hour or so, you stand below it, you will feel it's warm below that. Filament bulb is something which gets heated up soon. So in the filament bulb, there is this conductor, there is this filament which is made up of metal or alloy. I think it's made up of tungsten. Anyways, that filament, it gets heated up soon, not like this, unlike this. So when the filament gets heated up soon, what happens is its resistance increases drastically. Okay, so when the resistance increases, what happens? Resistance is equal to gradient for these graphs, so gradient will also increase. So we have to go for a graph where gradient is increasing. Okay, so I have drawn the graph in the positive side. You have to draw the mirror image of that in the negative side as well. Then you are safe always. Okay, so the reasons also I have explained. Based on the Ohm's law equation, we have plotted graph. This is Ohm's law actually. This is Ohm's law. Okay, why? Ohmic conductor is the conductor which obeys Ohm's law. That's why we are getting a graph like this. And this is the basic equation we used. And you need to know the reason to the variation of the shapes. And there is another electronical element called diode. It will have a different kind of graph, but let's learn about that in electronics. We can skip it. Sometimes they might expect you to plot graphs for I versus V. Now this one I have plotted for V versus I, where R is the gradient. Let's see what happens in I versus V graphs. When you say I versus V, you should be able to understand that I should be in y-axis. So I'll quickly write this equation again. V equals IR, and I have to make I the subject. When you make I the subject, this equation will get altered in this way. See, you keep I on this side, you take R to other side, so it will be 1 over R. Then I will write separately 1 over R into V. The graph will be like that. So here you can compare it to y equals mx, and just like I told before, on y-axis we will have current, on x-axis we will have voltage, and the gradient will be 1 over R, not R, it will be 1 over R, the reciprocal of the resistance. So the shapes of the graph will be the exact opposite compared to these things, but let's see. Let's draw the graphs here, same for same conductors, but this time I versus V, and let's discuss. Well, these are the three graphs for the same cases, okay? Ohmic conductor, semiconductor, filament bulb. Now what's happening here? For this, the gradient is 1 over R. Now if you come here, I'll just say gradient, I'll put G, okay, gradient M, let's use M is equal to 1 over R, right? If R is constant, 1 is anywhere constant, so M is also constant, you will get the same shape, okay? Same shape in the sense it's a straight line. So no need to get confused. When it comes to an ohmic conductor, it will be always a straight line. But when it comes to a semiconductor, now for these graphs, I versus V graph, the gradient is 1 over R, and we know for semiconductors, as you increase the current, temperature increases, so more charge carriers are produced, so resistance decreases. When the resistance decreases, according to this equation, the gradient must increase. So we have to plot an increasing gradient graph, and you know this is how a increasing gradient graph looks like, a curve, and you have to draw the mirror image of that for the negative side as well. Okay, mirror image of that. See, if I rotate it, yeah, it should look the same. See, I hope you can understand that. Yeah, and here again, not difficult to understand, gradient is equal to 1 over R, and we have figured out for filament bulb, when you increase the current, the temperature of the bulb increases, so the resistance increases. If the resistance increases, the gradient should reduce. So this is a curve for reducing gradient. See, look at the graph is eventually becoming flat. When any graph is flat, that means gradient is 0, so its gradient is reducing. And this also, if I rotate it on the other side, you will have the same shape. That is what I meant by mirror image. Okay, good. So you have to be, it's not rocket science, it's just everything is based on the one simple equation. But when you come across these graphs, you have to be absolutely sure about the axes. Is it V versus I or I versus V? Based on that, you have to choose the correct graphs. This is all about Ohm's law, not a very complicated theory part, just a small definition, and the small graphs, these simple graphs would